What is the area of an equilateral triangle whose inscribed circle has radius 2? And there's 4 numerical options given here. So I'm inclined to say it's going to be one of the results that has a root sign in it, simply because if the radius is 2 of the inscribed circle, you're probably going to have to use some kind of Pythagorean theorem to figure out the side lengths of this triangle. I think I'm just going to sketch a diagram and label the length that we know, which is the radius of the circle, and then just kind of go from there, see what happens. So it'll be easiest, I think, to label the radius here where the intersection with the radius in one side of the triangle is a right angle. So that's going to be a length of r. We'll substitute r equals 2 at the end of all this. And that there is, well, a triangle. I'm going to call this angle here theta. So we know that theta is equal to, well, 30 degrees, right? Which is what? Pi over 2 divided by 3. Yep, that's 30 degrees. Okay, and so what do we need here? I suppose what I really want is this length, x, because the area of this triangle that I have here, this small triangle, is x times r over 2, right? We have a base times a height. And there are 6 of these triangles in total that make up the equilateral triangle. Okay, so x is equal to what is it? Tan theta is r over x. So, well, and what is the area of one of these triangles? It's going to be rx over 2. So I have r squared tan theta over 2. That's the, I mean, oh, wait, no, not quite. Oops. X is equal to r divided by tan theta. Okay, and at the end of this, I'm going to have to multiply a by 6 because of the, there are 6 of these small triangles. Okay, so tan theta, tan of pi over 6, what is that? I'm just going to draw out a triangle here, so that's pi over 6. I think that's right. Never know why these trig ratios take me so long to remember, but I think this is correct. So tan pi over 6 is equal to 1 over root 3. Okay, so this 6a is equal to 3r squared times root 3. If I now substitute r is equal to 2, I get 12 times root 3. Is that one of the options? It is. That's option C. So I'm pretty confident in that now, given that all of my computations result in one of the options given. Yeah, I mean, I don't do this regularly. If I were preparing for any kind of test like this is the kind of stuff I would review in depth and memorize, so I don't have to spend 2 minutes remembering what these triangles look like. But this was pretty straightforward especially once you draw a picture. I think the most important thing here was dropping down that perpendicular, because that's also the radius of the circle, and then once you connect that, the geometry becomes pretty clear. It's really easy to find the area of that triangle there, as long as you know, well, if you know X and R, and there's 6 of these triangles in the big equilateral triangle. Yeah, nice little problem. Don't have much more to say about this one. Thanks for watching.